Have you ever imagined a colossal underground military city where hundreds of intercontinental ballistic missiles are meticulously stored hundreds of meters below the Earth's surface? A fortress impervious to even the most advanced weapons? Welcome to a new episode of Weapon Science. I'm Ethan Walker, and today we're dissecting a monumental mystery in modern military engineering, a secret city that redefines our understanding of defense. We often live under a false sense of security, believing that the world's most expensive weapon technology can obliterate anything. But what if I told you a multi-million-dollar weapon could be stopped by ordinary rocks? It sounds impossible, doesn't it? Many strategists claim modern conventional weapons have absolute penetration power, yet pure physics and geology prove the exact opposite. There's a mathematical limit in Iran's rugged mountain ranges. This limit cannot be breached by any military technology. What if science shows the deadliest 30,000-pound bomb is useless against Iran's mountains? This isn't mere speculation, it's a calculation based on fundamental physics. Iran has built a military city impossible to penetrate, not underground in regular soil, but hundreds of meters deep within solid, dense granite. In this weapons science documentary, we'll uncover the secrets of military engineering, kinetic physics, and geology that make this underground missile city an actual doomsday-proof fortress. Let's begin by dissecting the destroyer itself, the GBU-57 MOP. Prepare for a deep dive into the Earth's core, where we'll see how zigzag tunnels and giant boring machines change asymmetric warfare. Don't go anywhere. What you're about to see might change your view of global military power forever. The GBU-57 Mass Ordnance Penetrator, or MOP, is a 6-meter steel monster designed by the U.S. military for one purpose: to penetrate deep into the Earth before detonating with immense power. Its total weight reaches 13.6 tons. To give you perspective, this weight is equivalent to 3 adult elephants combined. This heavy projectile is dropped from a B-2 stealth bomber at extreme altitudes, maximizing Earth's gravity. The GBU-57's penetration ability isn't just its weight, it's its casing material. Over 80% of the bomb's weight is a super thick special alloy steel casing designed not to shatter upon impact at supersonic speeds. When dropped from the stratosphere, this bomb relies on basic physics. Gravitational potential energy is slowly converted into massive kinetic energy. The longer it falls, the faster it goes, and the greater its momentum. The hydrodynamic design of its sharp conical nose minimizes air resistance. More importantly, it focuses all that kinetic energy onto a tiny area upon impact. This is a direct application of pressure in physics. A large force divided by a small area results in extreme pressure. In optimal conditions, hitting soft ground or reinforced concrete, the GBU-57 is claimed to penetrate up to 60 meters before its delay fuse triggers the main explosion. This deep explosion creates artificial seismic waves, destroying enemy bunker structures from the inside out. The smart delay fuse, embedded in the bomb's tail, continuously calculates deceleration as it penetrates. It only triggers when it detects the bomb has stopped or reached a void. This combination of immense mass, high terminal velocity, super hard steel casing, and smart fuse makes the GBU-57 the most feared non-nuclear tactical weapon. Theoretically, no man-made structure can survive a direct kinetic hit. However, here lies the blind spot of this military technology. When kinetic weapons face massive, ancient, natural geological formations, physics works very differently. Physics teaches us that every action has an equal and opposite reaction. When the GBU-57 left the test lab and met the geographical reality of the Middle East, all its perfect penetration calculations were radically retested by nature. Now, let's enter the second phase, the absolute limitations of kinetic physics. The basic equation for kinetic energy is E equals 1 divided by 2 square millivolts. This timeless formula governs the destructive power of a bunker-buster bomb falling from the sky. While the energy generated is immense, there's one critical variable that limits everything: the target material. When the bomb hits soft ground or sand, the material shifts, slowly absorbing energy, allowing the bomb to slide down like a hot knife through butter. But the story changes drastically when the bomb hits hard igneous rock. Igneous rock has a very dense crystalline structure with no empty space to shift. When the bomb's nose strikes hard rock, its kinetic energy cannot be used to displace the target material. Instead, the entire massive kinetic energy bounces back into the bomb structure within milliseconds. This creates a highly damaging internal shockwave. Physics laws of stress and strain apply to the bomb's alloy steel casing, testing it to its maximum limit. If deceleration happens too quickly and violently due to rock resistance, the structural strength of even the strongest steel will break. In ballistic tests, high-velocity projectiles hitting granite often shatter into metal fragments or crumple like a crushed soda can. This is why the military can't just continuously increase bomb speed to boost penetration. The higher the speed hitting hard rock, the greater the destructive shock force the bomb itself receives. There's a terminal velocity limit where the bomb destroys itself before penetrating. Additionally, the smart electronic fuse in the tail is highly vulnerable to extreme gravitational shocks. If deceleration exceeds thousands of Gs in under a second, the internal microelectronic components can be totally damaged, rendering the bomb a dud. The solution for modern military architecture against kinetic weapons is elegant and simple. Give the target a shield denser than soil, thick enough for the bomb to exhaust all its kinetic energy just digging the first few meters. Even if the bomb maintains structural integrity and explodes at a shallow depth, the blast energy will take the path of least resistance in solid rock, bouncing back up through the hole it just made, not penetrating deeper. This understanding is key. This deep understanding of kinetic physics' absolute limitations forms the foundation of Iran's asymmetric defense strategy. They realize they don't need expensive anti-aircraft systems. They just need to let the Earth and physics do the defending. This brings us to the third phase, the geology of the Zagros Mountains. Iran's geography grants them an unparalleled natural defense. The Zagros stretch 1,500 kilometers, forming a colossal rock fortress protecting the country's interior. These aren't just tall mounds of dirt. Geologically, the Zagros form from ancient tectonic plate collisions between the Arabian and Eurasian plates. For millions of years, immense plate pressure compressed layers of limestone and igneous rock to extreme densities. Let's compare densities scientifically. Regular soil or sand has a density of about 1.4 to 1.6 grams per cubic centimeter. Even the strongest military-grade reinforced concrete is around 2.4 grams per cubic centimeter. But granite and metamorphic rocks deep within the Zagros are far denser. This high density creates what's known in mechanical geology as extraordinary, unconfined compressive strength. The rocks in these mountains can withstand hundreds of megapascals of pressure before cracking. Structurally, this mountain is stronger than any man-made bunker. When Iranian military engineers decided to build their missile city, they didn't need to pour thick concrete shields. Nature had provided a hundreds of meters thick armored shield of solid rock. They only needed to excavate its interior, utilizing the mountain's natural strength. Another geological advantage is the layered structure of the Zagros Fold Mountains. They consist of alternating hard and soft rock layers due to their tectonic history. This layered arrangement acts exactly like composite armor on a modern tank. When a bunker buster bomb tries to penetrate this layered formation, the density difference between layers causes the bomb's nose to experience lateral shear forces. This forces the bomb's trajectory to deflect from a straight line, making it move sideways. Eventually, its entire vertical momentum is lost, and the bomb gets stuck deep within the mountain, unable to reach its target. Additionally, these mountains have a network of microscopic faults and natural cavities that act as hydromechanical shock absorbers. If a large explosion occurs on the surface or at shallow depth, the generated seismic waves are broken and dispersed in various directions by this fault network, preventing them from reaching the main facilities below. Now, Phase 4. The genius of the mountain's internal architecture. A protective rock roof hundreds of meters thick isn't enough to guarantee survival. The biggest threat from bunker-busting weapons isn't the fire, but the blast's air shockwave. In confined spaces like underground tunnels, explosions create the channeling effect. Extreme high-pressure waves can't spread in all directions. They're forced to travel straight, destroying anything in their path. To counter this, Iranian military engineers never built straight main entrances. They designed the entire tunnel network in extreme, sharp zigzag patterns. This labyrinthine pattern of sharp turns every few tens of meters has specific acoustic and thermodynamic functions. Each time a supersonic blast wave hits a rock wall at a sharp turn, most of its kinetic energy is reflected back. Some is absorbed by the rock, and only a small fraction successfully turns into the next corridor. This energy-weakening process is known in wave physics as attenuation due to acoustic impedance. By forcing blast waves to reflect repeatedly at various angles, the deadly explosion pressure is exponentially dampened. After 3 or 4 sharp turns, the blast wave transforms into a mere strong gust of wind. Additionally, at each sharp turn, engineers typically add expansion chambers or artificial pressure relief pockets, dead-end empty rooms designed to trap and contain residual blast waves. This system also features massive composite steel blast doors, several meters thick. These doors are placed at strategic gaps between zigzag tunnel segments. If sensors detect extreme air pressure changes, these doors hydraulically close in seconds. Their convex shape efficiently distributes shock pressure evenly across the doorframe. This labyrinthine pattern not only protects against bomb blasts, but makes ground infiltration a tactical nightmare. Every tunnel turn is a deadly ambush point. Even if enemies map the main entrance via satellite, this internal zigzag design can't be seen from space. Firing missiles into tunnel entrances will only damage the first few tens of meters without touching the vital parts of the military city. This is proof that the best defense doesn't always need complex electronics. Sometimes basic fluid physics and clever spatial geometry suffice. By blending the geological resilience of rock mountains and shock-absorbing tunnel engineering, this underground missile facility becomes an architectural organism capable of absorbing, diverting, and neutralizing all kinetic attacks. Now, Phase 5, the pinnacle of absolute defense, extreme depth. All defenses discussed are merely additional layers. The most critical factor making Iran's missile city immune to bunker-buster bombs is the depth at which it's built. Satellite imagery and intelligence suggest the main facility is 500 meters deep under thick granite. Let's pause and absorb that number. 500 meters of thick granite is equivalent to burying a skyscraper like the Burj Khalifa vertically. Recall the GBU-57 MOP specifications. This most advanced U.S. bomb is claimed to penetrate a maximum of 60 meters. Again, 60 meters under ideal soil conditions, but their target is 500 meters deep in hard rock. This is a fatal mathematical imbalance. Mathematically and physically, conventional weapons become completely irrelevant. Even if the military dropped 10 bunker buster bombs consecutively into the exact same hole, in a technique called precision carpet bombing, the combined depth achieved would never approach the safe zone of the underground missile city. The peak moment of military power's illusion happens here. Imagine this 3D visualization. A GBU-57 bomb falls, penetrating the outer mountain layers at furious speed. Sparks fly, the ground shakes violently. But its energy is entirely exhausted, exploding at 60 meters, creating an insignificant crater. Meanwhile, 440 meters below the explosion point, the military missile city operates in perfect silence. Personnel there might not even feel the slightest tremor from the world's most expensive bomb. The mountain absorbs everything. The only theoretical way to destroy facilities at this extreme depth is with Earth-penetrating nuclear weapons. Such weapons use thermonuclear blasts to vaporize rock on a massive scale and create extremely powerful artificial earthquakes. However, tactical nuclear weapons have devastating geopolitical and environmental consequences, triggering widespread radiation and potential World War III. Therefore, the nuclear option is taboo and almost impossible in modern conventional military conflict. By placing their facilities far beyond conventional weapons' physical reach, Iran has achieved strategic invulnerability. They force their enemies to realize that conventional airstrikes, however technologically advanced, are futile. This extreme depth is not just a passive hiding place, it's a firm physics statement that the Earth's mass and density will always win against man-made projectiles. This is ancient geology's victory over modern ballistic science. Phase 6, how thousands of military personnel and ballistic missiles survive and operate underground for months without external support. The answer lies in a revolutionary self-sufficient logistics system. The biggest problem for an underground base isn't food or water, but pure oxygen and toxic gas management. This facility has an industrial-scale autonomous ventilation system, drawing fresh air from hundreds of small, camouflaged vents across the mountain surface. This artificial breathing system is integrated with high-level CBRN protection. If external sensors detect toxic gas or nuclear radiation, main valves automatically close, and the facility switches to backup liquid oxygen supplies. For internal movement, the missile city has an extensive electric underground rail network. This train system is designed to move ballistic missiles from deep storage to hidden launch silos closer to the surface. Electric locomotives are crucial. Conventional diesel engines would produce deadly carbon monoxide in confined spaces. Electric power ensures a clean, breathable environment. The rail system allows dynamic launch mobility. Missiles aren't fixed, they constantly move along the underground labyrinth. When ordered, a missile is brought to a launch hole, fired, and the train immediately retreats into mountain protection. Launch silos use hydraulic camouflage roofs. These roofs, made of natural rock, blend with the topography. When launched, the giant rock slides open for minutes, releases the missile, and closes, leaving no visual trace for enemy satellites. For energy, the facility doesn't rely on vulnerable surface civilian grids. They have independent power plants inside the mountain, likely thermal generators or small hydroelectric systems utilizing underground rivers. Rocket exhaust gas management during launch is also handled carefully. Special exhaust shafts direct thousands of degrees of heat and pressure safely out. This perfect integration of ventilation, rail transport, active camouflage, and energy self-sufficiency transforms dead rock tunnels into a living, breathing military ecosystem ready to retaliate at any time without appearing on the surface. Phase 7. How could a nation under heavy sanctions excavate millions of cubic meters of super hard granite so quickly? The answer is surprising. Chinese tunnel boring machines. Traditional excavation using dynamite is slow, risks damaging the mountain's structural integrity, and triggers tunnel collapse. Plus, continuous explosions would be easily detected by foreign seismic intelligence sensors. They needed a fast, silent, high-precision excavation solution. This is where civil technology played a vital role in military engineering. Through various trade channels, Iran gained access to giant tunnel boring machines made by Chinese infrastructure companies. These monster machines were originally designed for urban subway systems or cross-mountain water tunnels. A TBM is a modern civil engineering marvel. Imagine a walking steel factory, a cylindrical tube up to 100 meters long. Its front is equipped with a giant cutting wheel made of tungsten carbide, one of the hardest materials on Earth, slowly grinding away granite rock without causing major seismic vibrations. The TBM's main brilliance is its ability to do 3 heavy jobs simultaneously. In one forward motion, it excavates rock at the front, removes debris via conveyor belts in the middle, and automatically installs protective concrete rings on the newly dug tunnel walls at the back. This high level of automation drastically speeds up construction. It reduces the need for massive manual labor and produces very smooth and stable cylindrical tunnels. Architecturally, cylindrical tunnels have much better load distribution resistance than conventional square-shaped tunnels. The use of Chinese civil heavy equipment for strategic military purposes shows an interesting paradigm shift. The line between civil and military technology is blurring. A machine designed for public transport can easily build the deadliest doomsday-proof military fortress. With this underground armada constantly chewing through rock, the Iranian missile city network never stops growing. Every year, hundreds of kilometers of new tunnels are added to the Zagros Mountain labyrinth, making enemy intelligence mapping almost impossible. This is a testament to an unstoppable force, a growing network that defies conventional surveillance and military planning, ensuring its continued expansion in secrecy. It's truly a marvel of modern engineering. The conclusion of our long analysis today is a crucial lesson in asymmetric warfare. Military power isn't always about who has the biggest bomb or the stealthiest plane. Sometimes true strength lies in a deep understanding of basic physics and geology, and how to use nature's power against human technology. The GBU-57 MOP bunker buster bomb may be the pinnacle of modern kinetic engineering, a terrifying weapon on paper. But when faced with 500 meters of extreme depth, ancient granite density, and shock-absorbing zigzag tunnel designs, pure physics unequivocally declares that the bomb is defeated before it's even dropped. It's a testament to the power of nature and ingenuity over brute force. This changes everything. The question now is, with the increasing development of these underground defense systems worldwide, will the era of conventional air warfare soon end? Will the future battlefield shift entirely to dark battles beneath the Earth's surface? Please share your thoughts and analysis in the comments below. If this 3D animated visualization and scientific explanation helped you understand modern military strategy, don't forget to hit the like button and share this video. Make sure you've subscribed to the Weapon Science channel so you don't miss our next in-depth analysis. With me, Ethan Walker. See you next time.